Hey, today we're going to talk about the ideal gas law. This is another one of the formulas given to us on page 3 of our reference table. So it's really important you have your reference tables out. And we're going to be doing PV equals nRT, which is the ideal gas law constant. Some people call it PIV-NERT, just because of the letters that are involved. So if you ever hear me say PIV-NERT, I'm talking about the ideal gas law. Now, it's important that you understand what all the letters represent. Remember, that's given to you on page 3 of your reference tables as well. P is for pressure. V is for volume. N seems a little funny, but that's for moles. R is the gas law constant, and we'll get to that in a second. And T is for temperature. Now, you have to make sure that you're using the correct units. And that's because those units are going to specify which gas law constant R you use. So if you look on the front of your reference table, you will see R, gas law constant, and these three constants are given to you. The only difference between the three constants is the unit of pressure. So the very first number here, 0.0821, is used when we have a pressure unit of ATM. 62.4 is used when we have a pressure unit of millimeters of mercury. You might also want to make a note to yourself that that could also be in torr, because millimeters of mercury and torr are ultimately the same unit because they're both 760. So we can actually use millimeters of mercury or torr interchangeably. And then the last one is for kilopascals. So really important that you match the units of pressure to the R value that you're going to use. You want them to be able to cancel out or tell you what the pressure of unit is when you solve for pressure. You also have to make sure the other ones are in their correct units. So volume has to be in liters. That's what the gas law constant R tells us. All three of them have liters. So if you're given milliliters, then you would need to convert it to liters. So you move 3 places to the left, which is based on King Henry, Dad Unusually Drinking Chocolate Milk. If you have Celsius, then of course you're going to convert it to Kelvin, because you should always be converting to Kelvin for all of our math problems. And to do that, all you have to do is add 273. If you're given grams, then you're going to want to take those grams and convert it to moles. So you would set up a little table. And ultimately what you're doing is dividing by the molar mass from the periodic table for that gas. Finally, if you are asked to solve for the mass in grams, then you would want to first solve for N, which would give you moles, and then do a conversion from moles to grams. And so you would end up multiplying by the molar mass for that final answer. So we're going to work through 3 examples today. Here's our first example. We want to key in to what is given to us and what we are looking for. So first we're given 5 moles. So that is our N. Remember, mole is for N, and if you forget that, you can look on page 3 of the reference table. Next, we have 20 liters. Liters is our unit for volume. Then we have a temperature of 25 degrees Celsius. Anytime we have temperature, it has to be in Kelvin, so we're going to go ahead and convert that to Kelvin by adding 273. Notice that I kept the 1 decimal place, and that's because when you add and subtract, it's based on the fewest decimal places, and the only number given to us is 25.0, so we're going to end with a decimal place. Finally, what we're looking for is the pressure, so we're going to solve for P. Now, because we have 1 pressure, 1 volume, 1 temperature, and an amount, then we are going to use PV equals nRT, which means we need to have our units very specific. N has to be in moles, and it is, so we don't need to convert. Volume has to be in liters. It is, so we don't have to worry about converting. And then temperature, of course, is in Kelvin, which it is, because we've already converted that. So then we're going to solve for pressure. Now what we're missing is our R value, which remember is a gas law constant, and we can get that number from page 1 of our reference tables. Here in this problem, it doesn't tell us what unit it wants pressure to be in. So we could really use any of those three values for R, but I'm going to use the value 0.0821 liter ATM over mole Kelvin. Again, those units are telling you what everything else has to be in. So my volume's in liters, my pressure is going to end up being in ATM, my N value is in moles, or my amount is in moles, and then my temperature is in Kelvin. So now we can take PV equals nRT and plug in the values that we know. Now, something that I noticed in our combined gas law work that you guys turned in is you could set this problem up and then you didn't know how to solve for X. So remember that the one that you're looking for has to be by itself. So here I have X on this side, I need it to be by itself. So I'm going to divide both sides by my volume to get X by itself. Now when I do that, I can look at my units. Mole and mole will cancel because one is on top, one is on bottom. Liters will cancel because one on top, one on bottom. And Kelvin cancels because we have one on top and one on bottom. So that leaves us with ATM. So when I plug this into my calculator, my answer will be in ATM. So we get 6.12 ATM. And again, for significant figures, we go back to the numbers that were given to us in the problem. So 5 moles, 20 liters, 25 degrees Celsius, all of those had 3 significant figures. So our answer needs to have 3 significant figures. Let's try our second problem. Again, we want to make sure that we are labeling what we're given and what we're looking for. So the first thing that we're given is 425 milliliters of oxygen. And I know milliliters is for volume, so we're going to label that V. Also looking ahead, I noticed that there is one temperature and one pressure. So I'm going to be using PIV-NERT, or the ideal gas law, PV equals nRT. And I need to make sure that my units are going to match my R value. So I'm going to go ahead and convert milliliters to liters. So King Henry died unusually drinking chocolate milk. I'm going from the M to the U. That is 3 places to the left. And that would be 0.425 liters. The next value we have is 24 degrees Celsius. Can't do anything in Celsius. It has to be in Kelvin. So we're going to add 273 to our temperature. And we have a temperature of 297 Kelvin. Next, we have our pressure. So we'll label that P. What we're looking for is grams. So we're going to use PV equals nRT. We're going to find the R value. Now remember that R value is based on the unit for pressure. So since we're given ATM as our pressure unit, we want to use the value that also has ATM in it. So when it says how many grams, that means we're going to solve for the N in PIV-NERT, and then we're going to convert to oxygen. So first we're going to plug in our values. This time we're looking for N, which is on this side of the reaction or the formula. So we want to get it by itself, which means we're going to divide by our R value and our temperature, which is shown down here. And then we can cross out our units. So ATM cancels, liters cancel, Kelvin cancels, and that leaves me with mole. Now I used 3 significant figures because all of the numbers given to us in the problem had 3 significant figures. You might be thinking that we're done now because we've solved for an answer in PIV-NERT. However, the question asked us to find grams. So we're going to have to take another additional step and go from moles to grams. So we have 0.0157 moles, and we're going to convert that. So we're going to set up a table. We're going to bring mole of oxygen to the bottom and grams of oxygen to the top. And then hopefully you remember from Unit 2B that 1 goes with mole and the molar mass goes with oxygen. Now remember, oxygen's a diatomic, so it's not 16. We have 2 oxygens, so that's going to be 32. We multiply and divide, our moles will cancel, and that would give us a final answer of 0.501 grams of oxygen. Let's do one more problem together. Again, very important that you label what you're given and what you're looking for so you know what formula to use. So the first thing that we're given is 2,773 millimeters of mercury. Please do not be freaked out by such a large pressure number when you're in millimeters of mercury or torr. Those tend to be larger values. The next thing that we're given is grams. Now we can't do anything in grams. The only thing we can do is moles. So we're going to go ahead and convert that to moles. So we take our value, we pull grams to the bottom, mole goes on the top, and then hopefully again from unit 2B, you remember that the molar mass goes with grams. Now hydrogen is also a diatomic, so it's not just one hydrogen, but two of them. So the mass is 2.016, and that's for every 1 mole. Then our grams will cancel, and that would give us 14.5 moles of hydrogen. Now that would be our N value. So anytime you're given grams, go ahead and convert that to moles, and then that's your N. The next given to us in the problem is 12, Celsius. Well, Celsius is temperature, and temperature always is in Kelvin. So we're going to add 273, and we get 285 Kelvin. Finally, what we're looking for is volume. So we're going to be solving for V. 1 pressure, 1 temperature, 1 volume, 1 amount of a substance tells us we're going to use Pivner, PV equals nRT. So the only thing we have left to do before we plug in numbers is figure out what the R value is. Now here, our pressure is given to us in millimeters of mercury. So we want to choose the R value that matches millimeters of mercury. So 62.4 this time is the value that we're going to use so that those units match. And my volume then should also end up being in liters. We have our amount in moles, and then our temperature, of course, is in Kelvin already. So now we can plug in our numbers. We're solving for volume, which is on this side. So that means we're going to need to divide both sides by our pressure. And then we can cancel out our units. Mole over mole cancels, millimeters of mercury over millimeters of mercury cancel, Kelvin and Kelvin cancel. That leaves us with the liter as our unit for our answer. And so we have 93.0 liters. Let me know if you have any questions. Reach out through Remind, email, or Microsoft Teams.